Thanks. Hello, I'm Jamie Clark, and I want to tell you about some build improvements in Spectre 8.0. Now, we haven't released 8.0 yet, but it is coming soon. Jan Willem told you earlier about Spectre Flow, which will be in 8.0 as well. But here I want to talk about improvements to the Spectre engine as a whole. We're going to talk about just things that will affect build scripts, measure factory builds, and regular Spectre dives. If you were at last year's user conference, you might have heard us describe the DFG project. And DFG was a code word that stands for data flow graph. And it involves a big change in the way that Spectre processes data operations. It means better parallel processing. It means better caching, faster reading of text files, running multiple simultaneous requests while sharing data between those requests for lots of improvements. And we're going to get into the details from this presentation. So I've selected some example builds to highlight those improvements. And for each one, we're going to compare the timing between 7.2 and 8.0. And hopefully you'll get a feel for all the various ways that Spectre has been improved for this next release. So let's get started. First, this is a very basic test case. We're going to read a text file and we're going to write it to a CBase. This is the sort of basic mode of Spectre. In 8.0, we've modified Spectre's text input code so that instead of reading it from the beginning all the way to the end in one swoop, it now reads from multiple places at once in parallel. So imagine if you were reading a 100-page book and it was going to take you too long. Instead of doing that, why don't you get 10 of your friends? Each of you can read 10 pages of that book. The hard part is to make sure that you don't miss part of a row in the data. Or if you were, imagine if page 2 starts midway through a sentence and you don't want to get confused. So we fixed that problem in the engine so that we can put the data back together again. And as you can see, this produces a big boost in performance. Another improvement was in string sorting. Here we have an example. It's a large file with many unique strings. For string columns, the CBase format keeps the string column as an array of numbers, and each number indexes into a sorted string table. This is better for searching and comparisons at runtime, but it also means that we need to make sure those strings are sorted at build time. And here you can see that this build is much faster in 8.0, and part of that improvement is from the text change I talked about just a moment ago. But another part of that improvement is in the way we're doing the sorting. We are sorting the strings as we read them instead of waiting until the end to sort them, and we get a boost in performance for that too. Now, this is the part where the sort of DFG project comes into play. The way that the DFG works is we were able to take multiple graphs of data flow and merge them together into one thing. And we can see this example here, where Spectre can do multiple requests at once, make better use of the multiple CPUs while it's doing so. Here we're going to do 5 builds. This is 5 separate text files. We're going to build into 5 separate CBases. And in this chart, both of the bars are 8.0, and these are just different ways of running the same Spectre command. The first bar is what happens if you're in Workbench and you make a production script and you give it a fork, and then you have 5 commands in Spectre, so they're all going to run in parallel, and when they're all finished, the production script is over. That took 50 seconds. In the bottom example, I'm going to give Spectre the 5 build scripts all at once in one command, and that runs in one process on the CPU, and it saves a lot of time because Spectre can organize its time better than the CPU will, than the operating system will do. When the 5 Spectre commands are running simultaneously, they're fighting with each other for resources, but with one Spectre command, it can be more efficient. Now let's bring Measure Factory into the picture. I have an example here from a hospital operations factory. The data volume in this one isn't very high, but the complexity is there. It's got 14 different data sets, 98 build steps because of all the data flowing back and forth between those data sets. Now, in this case, those 98 build steps, when you run those in 7.2, each step sort of picks up where the last one left off. It reads the CBase that the previous step wrote. It does some more link rules, some more calculations, writes out a CBase for that step, and then the next one goes from there. Spectre 8.0 does this all as one process. Instead of breaking it up into steps, it pretty much lines the whole thing up as one giant flow. It runs that from beginning to end in process. It doesn't need to write out those intermediate CBases, and that's a big improvement. Another interesting wrinkle in this is that the factory involved here still runs plugins, and those plugins are implemented with integrator scripts. The integrator scripts are not as fast as Spectre scripts, in particular Spectre flow scripts, which we're hoping we can convert our plugins to use those flow scripts. And if we do, those will become part of that giant data flow graph that Spectre will run, and that will save a lot of time. Now let's go back to an ETL case. Here I'm going to read a CBase, I'm going to write back a CBase, and along the way I'm going to do some lookups, I'm going to add some new columns. Again, this is not a very complicated example, but you can see that like in 8.0 it is still much faster. It's not reading in a net text file, so we're not getting that benefit of the text input improvement I mentioned earlier. So Spectre is faster, but for what reason? What's the difference? Now, the big advantage here is from the DFG project. Instead of processing that script in a linear fashion, it's able to do a lot of those operations in parallel. To give you an idea how that works, I want to show you that script. Here's what it looks like in Workbench. You can see that it's basically linear because that's the way most build scripts that we write are structured. You tell it to do this step, you tell it to do the next step, and so on. And that's how it runs it. And that's how Spectre 7.2 processes it. But let's see what it looks like to Spectre 8.0. Now, this is not what it would look like if you opened it in Workbench. This is I altered the diagram to kind of give you an idea, but this is actually what Spectre 8.0 sees, that those lookups are not related to each other, at least not in a data dependency fashion. And so it's able to run them in parallel. And that's the magic of this DFG project, and one of the reasons why Spectre 8.0 is going to be so helpful. Now, the last thing I want to talk about is how it can help script developers. If you're working on a build script or you're working on a measure factory, you'll frequently have the experience of making some change to the script, and then you want to test it. When you run that script, you see if it worked the way you want it to. If not, you maybe make another change, and so on. You're going to go through this cycle of build and test, change it again, make some more, do some more tests. That cycle can add to the time it takes to do this development, especially if the builds are very long. But now Spectre 8.0 has a feature where it remembers the data from the last build. And when you make a small change to the script or to the factory, it doesn't need to do all of the work. It just picks up from where that change happens. So in this bar chart, I've got some examples. The first is just this initial build of a fairly small CBase with some operations in it. The second bar is when I asked it to build it again. I made no changes to the script and I said, build that again. It only took 1.6 seconds here. And the reason is because it just needed to pick up the data it had from before and write it back out to that CBase. It's pulling data from the cache and then writing it out to the CBase. In the future, I think we can even get rid of that if we notice the timestamps are better. The second example is I've made a change to this build script. I modified a calc to have it have a different definition, and I do a rebuild. Same amount of time, 1.6 seconds. And the reason there is that it had to do very little work. It took the data from the cache for all of the other columns, and it only needed to rebuild one column before it wrote that back out to the CBase. And then the last bar, I changed the lookup file. Now it has to read that lookup file back in because it doesn't know what in the file has changed, so that takes a little more time. But again, it only ran one lookup out of the 7, and it didn't need to run many of the other columns. So we're hoping that this can save you a lot of time during development by allowing you to make small changes and see the results quickly. So in summary, with Spectre 8.0, we've got many performance improvements from text inputs, string sorting, running multiple requests in parallel, and sharing data between them, and caching the data from previous builds. There's a better developer experience when you're working on scripts. And this also lays the foundation for the future. I want to make some changes next to DivePort to take advantage of this. When you're opening a page in DivePort, it runs multiple requests for each of the portlets. I want to merge those together into one request so that Spectre can take care of them all simultaneously. So that's Spectre 8.0. The next thing I want to talk about is another 8.0 change. This time it's in DivePort. So DivePort 8.0 has a new change to the portal database. The portal database is where DivePort stores all the pages and all the portlets and the configuration for those portlets. We've changed that format a couple times through the years, and 8.0 is another example of that change. We've got a new file format for 8.0. The reason for this is it will improve performance when you're making changes to pages, and also will open up some ideas for the future, which I'll tell you about in just a moment. But the key thing here with this change is that DivePort 7.2 stores all of the pages in one portdb JSON file, which can get very big. And DivePort 8.0 will store those in separate page files. Each page will have its own file. They're much smaller, and there's much less to track for a given page. Now, DivePort always creates automatic backups in the database backups folder. So whenever you do a migration and you need to go back, you can find those and restore your content from before. 8.0 has a special feature. If you make some changes in 8.0 and still want to go back to 7.2 but keep those changes, portaldb v2 JSON file will help you with that. So the reason for this page files change, again, better performance when you're editing pages, but also this helps us for future ideas. Imagine if you had these page files that are currently in the portal DB area, but put them into Workbench projects or store them on DiveLine. In that case, you could reuse those across portals, for example. Also, in the future, I'd like those to be parameterizable, and then you could maybe have multiple pages in your portal that use the same page file and share content. So that sums up Spectre and DivePort 8.0.